C mathematical operations are a group of functions in the standard library of the C programming language implementing basic mathematical functions. All functions use floating point numbers in one manner or another. Different C standards provide different, albeit backwards compatible, sets of functions. Most of these functions are also available in the C++ standard library, though in different headers. Overview of functions. Most of the mathematical functions are defined in MathH. The functions that operate on integers, such as abs, labs, div, and ldiv, are instead defined in the stdlibh header. Any functions that operate on angles use radians as the unit of angle. Not all of these functions are available in the C89 version of the standard. For those that are, the functions accept only type double for the floating point arguments, leading to expensive type conversions in code that otherwise use single precision float values. In C99, this shortcoming was fixed by introducing new sets of functions that work on float and long double arguments. Those functions are identified by F and L suffixes respectively. Equals floating point environment equals, C99 adds several functions and types for fine-grained control of floating point environment. These functions can be used to control a variety of settings that affect floating point computations, for example, the rounding mode, on what conditions exceptions occur, when numbers are flushed to zero, etc. The floating point environment functions and types are defined in FENVH header. Equals complex numbers equals, C99 adds a new complex keyword that provides support for complex numbers. Any floating point type can be modified with complex, and is then defined as a pair of floating point numbers. Note that C99 and C++ do not implement complex numbers in a code-compatible way, the latter instead provides the class std complex. All operations on complex numbers are defined in complex H header. As with the real-valued functions, an F or L suffix denotes the float complex or long double complex variant of the function. A few more complex functions are reserved for future use in C99. Implementations are provided by open-source projects that are not part of the standard library. Type generic functions equals, the header tgmathh defines a type generic macro for each mathematical function defined in MathH and complex H. This adds a limited support for function overloading of the mathematical functions. The same function name can be used with different types of parameters. The actual function will be selected at compile time according to the types of the parameters. Each type generic macro that corresponds to a function that is defined for both real and complex numbers encapsulates a total of 6 different functions, float, double and long double, and their complex variants. The type generic macros that correspond to a function that is defined for only real numbers encapsulates a total of 3 different functions, float, double and long double variants of the function. The C++ language includes native support for function overloading and thus does not provide the tgmathh header even as a compatibility feature. Random number generation equals, the header stdlibh defines several functions that can be used for statistically random number generation. LIBM, under Linux and FreeBSD, the mathematical functions are bundled separately in the mathematical library LIBM. Therefore, if any of those functions are used, the linker must be given the directive lm. There are various LIBM implementations, including GNU-libc's LIBM, Sun's FDLIBM, which was used as the basis for FreeBSD's MSUN, which in turn is the basis of Julia's OpenLIBM, ARA Copyright Near Project CRLIBM, AMD's LIBM. See also, C99 floating point support. References. External links, MathH, Mathematical Declarations are Euro-based definitions reference, the single Unix registered trademark specification, Issue 7 from the Open Group, see reference for math functions.